Hey everyone, welcome to the Zephyr Podcast. This is episode number 4. I'm Benjamin, your co-host.
I'm Fabio, your other co-host. So Benjamin, I've heard you've been places. How was the Think conference in Amsterdam?
Yeah, just back from Amsterdam.
Okay.
It was short but pretty intense. I think some of the folks listening to the show, I've heard about either the Things Network or the Things Conference or maybe the Things Industries. I think they've been running this show for over 10 years. I think, was it the 10-year anniversary? I should know. I was there. But it's a really cool conference. It was 2 days of sessions like workshops and keynotes and so on. And historically, for those who are familiar with the Things Network or the Things Conference, this used to be LoRa 1, because that's what happened, right? Like when 10 plus years ago, Vinke Johan created this nice open LoRaWAN network. Originally that's what the community was all about. And for many years, it was actually really impressive to see how they were managing to gather a crowd around only LoRa and LoRaWAN, you could say. But this time around, this year, this was meant to be a more generic IoT conference, I guess. And so lots of LoRa and LoRaWAN still, but sort of expanding it a bit, right? And so Zephyr was pretty visible there, and like companies, not names that come to mind are like the likes of like Seed Studio or M5 Stack / Espressif, showing like all sorts of embedded / IoT sensors and equipment, or companies like more in the business of like power profilers, like I think Koitek, right? They do those solutions, and I don't mean to sort of name drop companies there, but just giving people a sense of what was going on there. And many silicon vendors, and all of them are basically really active in the Zephyr community, right? Microchip and Scilabs and NXP. And I'm sure I will be forgetting a few. Nordic was there as well. Arduino was really big and showing lots of they are all the stuff they have for education, but also all the stuff they have for more like professional makers and like PLCs and so on. And so I think they started to put the videos are starting to show up on YouTube. So there were like several tracks in parallel. I gave a Zephyr talk myself, and there were a few other Zephyr presentations. I'll put a link in the notes for people to check out the Things Industries YouTube channel. I think in the next few days or so, things will start to show up. But yeah, it was really nice.
That's very cool. You mentioned Seed Studio, and I remember when they started doing the LoRa modules, which was pretty cool, fairly simple to use and to implement. And I think after a while, they started doing complete devices as well, like actual final devices with a box and the sensor and everything. And they did present some in Prague as well. So tell me something. I attended the conference many years ago, actually, when it was exclusively LoRaWAN. Did they, at the time, they had a wall full of IoT devices? Did they still have the device wall?
They do, and interestingly, and on the Zephyr project's LinkedIn channel, if people are interested, we put some pictures of what was on that wall. So it's huge, and it's lots of, again, historically LoRa and LoRaWAN devices, but now it's more. And if you check the Zephyr project LinkedIn, you'll see that on this wall there was like 10 plus devices that effectively are Zephyr devices. Those devices from Seed Studio that you just mentioned. There were a bunch of Arduinos as well, like Opta and so on. Some asset trackers from IRNAS and others. In Infineon also, I think they have like a smart label, things that are like really low power, battery powered, and that one way or the other ran Zephyr, so that's pretty cool. And quickly, since you mentioned, Seed Studio, a couple of things that come to mind. Yes, they have those really nice like weather stations and so on, like based on LoRa, really ruggedized LoRa and LoRaWAN based devices. I think it's called the SenseCap, right? And so they were showing like new iterations of that. And also something that's a question I have for you. This is something that's on your radar, but Seed is doing a lot about LoRa and LoRaWAN, and which these days is very applicable in the context of Meshtastic, right? Have you been playing with it? And or do you know whether anyone in the Zephyr community has done something with Meshtastic?
That's a great question. I have not, and I've been meaning to do it for a while. So for the listener, this is a mesh network for tracking yourself, for doing stuff like hikes in areas that are not connected by the wider cellular network, and it allows to send a location update and messages. And as the name implies, it's a mesh technology. So it relies on relaying information from a node to another. See, that's some good thing.
Yeah, and people have been using it also for like I think Burning Man was just a few weeks back, and it was pretty big there from what I saw, because people also use it to set up like local networks that you can use for like texting and for like having local like group chat and so on in areas where either there's no coverage or for whatever reason you want to use some kind of like private messaging solution. And so yeah, folks use those like maker devices where like you have a small keyboard and usually ESP32 and like some kind of LoRa connectivity. It seems really cool. Just like you, I guess I haven't really looked into it, but maybe people, some of our listeners have been doing some cool stuff. I would love to hear.
Yeah, the network supports gateways as well. And if you go on the project website, there is a map that shows where the public gateways are. And unfortunately, there's not much in my area. So maybe it would be a good chance to set up one. I actually have a LoRaWAN gateway in my home that is serving the bay. But yeah, Seed Studio does a good module. The original module for Meshtastic looked, they looked like a proper maker board. They weren't very polished, let's say, but with what Studio did, I think it's a very good technology. So, tell me about your talk. What was it about? How did it go? Or unless you want us to wait for the recording, I can't wait to see it.
Well, the talk was only 15 minutes, so if I talk about it now, probably people don't even need to watch the recording. But yeah, no, it was about Zephyr, obviously, and sort of using the excuse of Zephyr turning 10 in just a few months. By the way, hint, hint, this is coming up really quick. Probably Embedded World will be where we will be celebrating it. So to keep that on your agenda, I guess. And so, I walked people through some of the things that made Zephyr successful, which, in hindsight, some of the decisions we made since day one, initially, some people maybe thought that, hey, you guys are doing like way too many layers of abstraction. This won't work in embedded. We need to have control and like abstractions over abstractions. This is just going to bring bloat and so on. That's not what we want from an RTOS. But well, effectively, when you look back, like after nearly 10 years, that's also what enables like innovation and enables like this rich ecosystem of modules and libraries that you can easily compose. So talking about like the usual suspects like kconfig and device tree and like all those things that help basically have embedded development embrace and adopt some of the techniques that typically embedded is lagging behind with things like continuous integration and just like I said, like having layers of abstractions. Like when you think backend frameworks and like JavaScript frameworks and whatnot, like this works to have to have nice APIs and frameworks to not having to reinvent the wheel all the time. For some reason, in embedded, it's not always as popular, except for HALs, maybe, I guess. But yeah, talking to that. And so yeah, check out the recording. I think it was a good tour of some of the, sometimes also what I call the hidden gems in the Zephyr ecosystem. Again, doing sort of the parallel between yeah, and the fact that embedded is sometimes lagging behind in terms of modern software engineering techniques, all things testing. I spent a few minutes talking about Twister, which is getting quite some love actually these days. And so Twister in Zephyr is this tool/framework that helps people run tests, and tests that can be like really basic integration tests, or things that are more substantial, like you want to test that the product that you're building, you want to test the power consumption, and like every night in your lab you run some test cases to make sure that you remain in the sort of power budget you have in mind, or you point a high resolution camera at the LCD display of your device and you test that your GUI, your graphical user interface, is pixel perfect. Like that's part of the Zephyr ecosystem. And again, like, typical embedded developers, I mean, I don't want to like offend anyone, but for some of them, like, I mean, yeah, automated testing, like they maybe never thought about it, right?
Yeah, I mean, this stuff, it's easy to get there as an afterthought. Like one may start a project, get all excited and implement all the features, but then when it's time to release it to the world, you start getting breakages and regression, and at that point you need a framework for doing continuous integration, and the project having one is a great advantage. But yeah, hey, you also mentioned you mentioned batteries and energy and power management, and yeah, it's worth calling out all of these devices have to, but most of these, I imagine, they are battery powered, right?
Yeah, there were some interesting discussions and talks and so on. Companies, for example, like that sell like really efficient solar panels or like solar cells that you can put on your design. Or I think it was Silicon Labs. Yeah, here, that's one that I forgot to mention. Silicon Labs was there, and don't think I mentioned it. And they use, of course, Zephyr quite heavily. They were showing some solutions for energy harvesting. And like anytime I was like listening to one of those talks, I was like, yeah, that's actually interesting, because in Zephyr, I think we have actually quite a few things to help people do manage energy and so on, right? We have many like subsystems and APIs for interacting with fuel gauges, or like with regulators to like really efficiently control and turn peripherals on and off based on usage. What else do we have?
Yeah, battery charger is also an important one. A lot of these devices have a configurable charger, and power management itself, really, the whole power management situation is actually fairly complex. It's pretty hard to get it right. But yeah, Zephyr does have an infrastructure for managing both the system power management, as in managing the CPU switching to low power states, and it's implemented by various SoCs, but also device power management, which means having a framework to be able to shut off some specific devices when you don't need them.
Yeah, and so that's, I mean, that might be the topic of a like a dedicated episode or something. But what I like with Zephyr is that out of the box you get it's already pretty efficient in terms of power management and so on. And if you want to like start, you as a developer, you want to tweak things manually and so on, it gives you lots of flexibility as well. But yeah, there was someone who made a sort of like, I mean, not a joke, but more like sharing a thought that stuck with me, which is, and that was exaggerated, of course, but when you build an IoT device, like if it has a battery, that's a problem. Like that's not sustainable and so on. Which is, it's kind of true. I mean, you do need a battery probably, but you need to also think like can it actually maybe work even when you don't have a battery? Have you thought about doing maybe energy harvesting so that you can have something that's like more sustainable and yeah, so then yeah.
Interesting. So I was listening to a podcast probably while you were giving your talk earlier this week, and this was Reliability Matters. And the host was talking about IoT, and he described IoT as the process of taking electronics and putting it in things that don't need it, never had it, no one wants it, but we do it because we can. What do you think about it after a few days of IoT?
Yeah, well, interestingly, and I won't say names, but as happens with all conferences, there were a few talks that were like very obvious product pitches, and some of them probably for technologies that, yeah, I mean, it's there because we can, but is it really like solving real problems? I think that's the world we live in, right? When we do
Yeah,
technology, we could tell the same with like AI. Many people these days, they would do AI because they
because we
can. Is
can.
this, do we really need it? I think we do in some areas. It's like solving real problems. There was actually, I don't know if you saw that one, Fabio, but someone posted on our Zephyr Discord yesterday. I think it's the Fedora community. They are in the process of adopting guidelines with regards to how they want to deal with AI contributions and like AI assisted pull requests and code and so on. And that's interesting because they sort of acknowledge that, yeah, there are some times where this is useful. And even like the wording was, I felt sort of impressive in a sense for such an open source project. They were explicitly saying we we encourage AI contributions, which was like, wow, really? Like Linux, like Fedora guys are like, but that's great. I mean, that's basically acknowledging that if you do it right, as always with technology, if you do it right, then yeah, you should totally do it.
Yeah, I mean, this is an extremely young technology. So I think it's understandable to think that projects have to dial in the right amount of it to make it usable, convenient, but also not to make it a problem, right? So I think that the way that Fedora worded it was very fair. I don't think we took a stance on it yet, but we probably should. This was a topic when all the AI coding tool exploded, maybe a couple of years ago, and it's been relatively quiet. Somebody actually asked me at ZDS if we had problems with it, and not really. I don't think I've seen many AI swap pull requests, not enough to justify making a
What,
problem out of it.
you
But we've
mean
seen.
problems as in being overloaded with
Yeah,
noise and yeah,
exactly.
I don't think so. Yeah, there's been a few like certainly there's been
Yeah,
a few just random code dumps where the author didn't even well. And one thing actually that the Fedora community encourages people to do is that whenever someone makes a contribution that one way or the other was AI assisted, mention it. Like, don't try and
mm,
hide it. Just like, hey, FYI, there's no problem about that. Like, and as long as you understand whatever code you've put together with the help of some kind of assistant, just and if you're able to talk to it and to iterate and fix it, if you're asked to do it, I don't see any issue with that.
right. Yeah, polarizing topic anyway.
Yeah, totally.
You'll feel good. Very good. So
While I was gone, what happened? Did you see some interesting pull requests this week or stuff being merged?
yeah, the merge window. I've been busy as always. So yeah, there's few things that we can probably mention at this point. So the subsystem wise, the OPAMP subsystem have been merged. So this is a fairly simple thing. Right now, there's only a single API, and this is to cover devices on SoC that implement essentially a programmable gain amplifier. So yeah, you can check the pull request. Right now is implemented only for some NXP platform.
And so, and do you think that's really only for peripherals that are like on board the on the on board like on the SoC. Like I'm sure
No,
there's some external ICs that are
yeah,
effectively op amps as well, right?
yeah, and I'm pretty sure that this is gonna see some use because they're useful devices, and yeah, you find them around.
Wait. There's one thing that so we just mentioned actually just before the regulator API and subsystem. Like, is it like wouldn't that actually fit in the regulator API where we have like set current limit and like should we have?
No, I don't think that I think that the regulator thing is mostly handling dependencies between devices and their supply rail, having the reference counting, and having the power rail shut down automatically when all the reference are lost.
Right. It
Why?
also has like the current limit and the voltage limit
Yeah.
sort of thing, which feels like
The,
the gain maybe would be what?
there's always a bit of overlap with these things.
Yeah. Yeah.
Yeah.
But yeah, no, that's cool. That's and what I like when those subsystems come in is that people putting my documentation manager hat on will take the time to like write code samples and document the API. Although in this case, like you said, API is pretty straightforward, but still taking the time to make sure that it has good documentation. This is always nice and appreciated.
Yeah, you want to build it right the first time, not changing it a million times.
Yeah.
So beyond that, we had the usual train of boards that have been merged, and actually one that we mentioned last week got in. This is Eve keyboard. The
Oh right,
series
it
one.
wasn't merged when we spoke
Yeah,
about that
yeah,
salvaged keyboard from the
yeah.
from
It was a bit of a gamble. We thought it was going to get in, but no, it's been merged now. But she wrote a blog post as well, just doing the reverse engineering on the keyboard, and yeah, it's really interesting. There's some good stuff in there. One of the thing that I found interesting was that there's a mysterious component on the keyboard that hasn't quite been identified. This is like an SOT 6-pin with a big thermal pad. So looking at it, it looks like a high-power device, but it's used for redriving the rows, which doesn't really make much sense. And that is something that I've never seen on a keyboard, interestingly enough. And one of the side effects of that is that it prevents you from swapping rows and columns because it's unidirectional. So that was fun. She thinks it's an op amp. I tried to search a bit as well, and I think she's right. But yeah, that was surprising.
Yeah, and like I really encourage people to check out the blog post. It's like a really nice and fun and like really great read. Just like pretty much every blog post on her blog. So check that out for sure. I think I saw a Raspberry Pi keyboard as well. Well, I guess it's not like necessarily Zephyr related from what I saw, but
Yeah,
tell me about
this
it.
is the keyword. Yeah, so Raspberry Pi, they always make a ton of noise when they release any products. So Raspberry Pi released another keyboard, or rather, it's a keyboard that comes with a Raspberry Pi. So this is the evolution of the Raspberry Pi 500. So this was the small keyboard with an embedded Raspberry Pi, the chip. So it's a single computer with a keyboard. And back when they did the 500, I remember that all of the noise, all of the community drama was around the fact that the board had the footprint for a connector for an M.2 drive, but they did not populate the connector and the power supply. So people wanted to use it with an NVMe, and they couldn't. So that was after for a while. But yeah, this week they came up with the 500 Plus, and it actually looks like a really cool product. So this is same concept, but it has mechanical keys, LEDs under every key, and this time they did put an NVMe connector. It's also $200. So
Yeah, I was gonna ask you. Okay,
yeah, and it does not run Zephyr, but maybe could, maybe should.
Yeah. So what is in there? Like, it's a compute module. What is?
No, this is actually a single board design. It does not use the compute module. So the board, this specifically is two boards. There is a dedicated board for the keyboard, which uses an RP2040, and that is all of the LEDs and not much more. And then the main board it's a single board design. So the Broadcom chip and all the connectors are there. And it's interesting that the keyboard is effectively an isolated piece of hardware. I don't think that they released the code yet, at least not when I checked it. But the previous one was using QMK, so I presume that this is going to use QMK as well. But yeah, this is one worth checking out, and I'm looking forward to see if somebody does a port of ZMK for the keyboard. That would be interesting.
I'm pretty sure we will see that happen. Yeah, that'd be cool.
Cool.
Also, all other boards. I think our friend Jonas is still at it with new shields.
Busy.
Yeah, still new shields. I saw an Adafruit solenoid shield, which is kind of like we would usually get like sensor shields and like really like classical, I would say, kind of sensors and so on. Solenoid shield, interesting. Like, where did you see that one?
Yeah, I did. Yeah, so this is an 8-channel solenoid driver, and I guess you could use it if you want to drive some solenoid. And it's pretty funny. I actually have a solenoid on my own keyboard to simulate the clicking. But yeah, if you need 8 of them, I suppose this could be the one for you. It's a fairly simple design, actually. When I looked it up, I thought it was something more refined. So this is essentially an I2C port expander, and it has driver for the solenoid and the anti-flyback diode so that you don't burn the MOSFET. Something that I haven't really seen in the wild. I worked a bit with inductive load in the past, and one thing that is done on this type of devices when you need to drive many channels, is that you don't really drive the solenoid only on and off, but you tend to do a pick and hold kind of deal. So you do a full drive for a few milliseconds, for a few hundred milliseconds, so that the solenoid engages. But then once the solenoid has been pulled into the coil, you don't really need to keep dumping all of the power into the coil itself for that to retain. And so typically you would reduce the duty cycle of the drive signal. And there are chips that do that in hardware. One thing that I've used in the past is DRV120 from TI. It would have been interesting for this board to do it, because if you're driving 8 solenoid, there's a lot of current. So the first problem is the load on your power supply, and the second one is burning the coils.
And could it be that do smart solenoids exist, which would actually be the ones taking care of, right? Rather than the driver, it would be the solenoid itself, which would be.
Well, this is designed to drive the coil directly, so it wouldn't be the drive. But I suppose you could do it.
Yeah.
Anyway,
one thing that one thing that I encourage people to do, and what I like with those shields, is that usually, that helps you prototype stuff really quickly. Like you add new functionality to an existing board, and in this case, what I like with the documentation that Jonas put together is that it puts the spotlight on our shell, which many of you probably heard me talk about many times, but the Zephyr shell that helps you to have basically a command line to interact with GPIOs and I2C and sensors, etc. And so he put together a bunch of instructions on how you can use the GPIO shell module to effectively control, like one by one, all the channels and what it takes to control the solenoids that way. So quite a nice and smart way to demonstrate the functionality.
Very good. So did you see the support for the SF32LB52 from Gerard? Like
what I did see is that it seems to be a board or slash an SoC that Pebble is going to be using to sort of like, I don't know, like they're probably doing some kind of rebirth of their smartwatch. I don't know. Did you own a Pebble yourself?
No, not really.
Okay. But so apparently they're going to use Zephyr for like a bootloader or something. And so that board just got merged. I think we brought like it comes with a HAL as well, like from this particular silicon vendor? Anything specific that the board does? The dev kit has an LCD, so I guess one can build their own smartwatch with it.
Yeah, so the company is a C-Fly, which must be one of those Sci-Fly, yeah, one of those fabless Chinese company. I never heard of it. It looks like an interesting chip, and since they hired Gerard, I guess they're gonna get some very very good quality support in Zephyr. So looking forward to see what they're gonna do with it.
Yeah, and then another board from Renesas. So this time not for solenoids, but for motors, the RA8T2, which I think just got merged as well. What have you seen about this one?
Yeah, what I've seen is that the board actually comes with a motor. So it's always fun when you look into this motor controller very specific developer kit, because sometimes they come with weird things. So this is actually a set of boards apparently, and it seems like they give you a board for the main SoC, a board for the BLDC driver, and an actual motor so you can try it. And this also has 2 Ethernet and 2 transceiver, and I was trying to figure out why. And this is because the chip is specifically designed for doing EtherCAT, which, if you don't know, it's an interesting field bus technology that is used for low latency process control over Ethernet. It's very proprietary, unfortunately, but it's also very interesting to study. The way I like to describe it is token ring implemented using Ethernet PHY. We may talk about it in some other episode. Like I played with it a bit, never used it in practice, but it's very interesting board. I like these weird things that are very, very, very specific.
Nice. Right. So I think that I don't think I saw anything else in the news. Oh, there's also unfortunately, at least I myself, I haven't had time to look at it in details, but from the name at least, it looks pretty interesting. There's an ADC streaming API, which we should probably have I don't know if you had to look yourself, but it's it seems like it will be interesting for people who have like use cases where they need to have like high throughput and so on.
Yeah, this is part of the whole RTIO subsystem, right? Yeah, I don't have much experience with that, but I know a few people that are working on it, and it seems like it's a very good feature.
Yeah, this is one of my name dropping moments. Louis, Tom, if you're listening to the podcast, I want a tech talk. We should do a deep dive about all things RTIO, because it looks so powerful, and I would love to learn more, and I'm sure people would love to learn more about it. So yeah, that's pretty cool. One thing that we mentioned last week is the developer survey.
How many answers did we get from the developer survey?
We are launching it today. We were not quite ready last week. It took us a few more days to set it up and so on. So this time, please do check out the show notes. zephyrproject.org/devsurvey2025 will be the short link, so you can you can go check it out. I think I may have mentioned that in previous episodes. It's going to be it's pretty short. It's really like tick a few boxes, and more importantly, use those free form text fields to do your brain dump, like of things you would like Zephyr to be doing differently, or more of, less of. If there's just one thing that you do and that's only filling writing text, that's great. Like that's what I personally would like to see. If you also have the time to tick the other boxes, that also helps. But the more personalized feedback, I guess, is the one that is usually the most valuable. So yeah.
Yeah, we read them, and they do get mentioned when taking decision in the TSC process architecture. we do care about the opinion of the user, trying to make it a better system for everyone.
Yep. So please, watch, look for the link in the notes. And with that, this was your weekly episode of the Zephyr Podcast. We will be back next week for a new episode. Bye.
Bye.